Dijkstra's algorithm for getting the shortest path is really important. When I was at Microsoft, I used to hear about it every day. Now, it's not strictly speaking an AI algorithm, but when added to an intelligent agent like this, it makes it more intelligent because it can find its way to any given location. So I like to count it as one. In this lesson, I'll show you a basic way to implement Dijkstra's algorithm in JavaScript. If you haven't been following along with the self-driving car codebase, you can take the most recent version from here. And don't worry, we'll implement almost everything from scratch, so you don't need to know the things there really. The reason we're using the codebase in the first place is because it makes testing easier, and eventually we'll teach the cars to follow the path. You'll see. Now, let's see if I can help you learn this new algorithm in the fastest way possible. Get it? Because Dijkstra can also give the fastest. No, no, no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
We will implement the algorithm for calculating the shortest path in the graph object, which is in world.js, and then math, and the graph is here. Now, this file is pretty big, but it's just a graph implementation. It has points and segments, or nodes and links, or vertices and edges, depending on the terminology you want to use. I call them points because this is a spatial graph, and the nodes do have physical locations there, so I prefer this terminology in this case. And all these functions are not really important for us at all because they are for constructing the graph, adding, removing points and segments and things like that. The only method that we will use is this get segments with point. So given a point in the graph, we will get all the segments that are connecting to it. And below this one, we are going to start to implement our algorithm. So get shortest path between 2 points. So let's call these start and end. And this method is going to create a path in this path array. And to debug, to see how the algorithm is progressing as we are coding, I'm just going to add to it the start and the end and see if we can make these light up in the interface. Let's return the path, save the file, and we are going to be modifying the graph editor here to also display the shortest path. So let's open this one, and all the way at the bottom in the display method at the end, we are going to calculate the shortest path on the fly. So path is equal to get shortest path between 2 points. And I'm just going to take out the graph point of 0, the first point, and the last point. So graph points of this graph points dot length minus 1. This is just for debugging a first version here. Now let's display these. We are going to loop through every point of the path like this and draw it on this context, the canvas associated with this graph editor. Now let's save and open the index.html from world, not the one here in the root folder, the one from world here above this one. And it's going to look like this and doesn't seem anything special, but if you look closely, this point here is darker than the other ones. Let me zoom in a little bit. You can see it's clearly darker because it's drawn twice. We are also drawing it now, the start and end locations. And this is the last point that was added when constructing this graph. So this is also darker. But let's mark them a little bit better. We can add here, for example, a size, maybe 50, and let's give it a blue color as well. And when you refresh, you're going to see this much clearer here, and the endpoint is now there. So the algorithm works by expanding, starting to expand here at the start point and growing and growing and growing until eventually reaching the endpoint. Let's start this expansion from this start point and see if we can get to this other point here. Going back to graph.js, and here I'm going to get all the segments that are connected to the start point. In this case, it's only one there, but there can be more. So segs is equal to this get segments with point, the start point. And that's this method from here. And looping through all of these segments like this, I'm just interested in the other point, the point that is not the start point. So let's take it out like this. Other point, we check if the first point of the segment is equal to the start. And in that case, we return here P2, otherwise P1. So whatever start is, we get the other point. And let's add this one to the path and see if it lights up. So path, push, other point, like this. Let's save this and refresh, and you're gonna see here both of these lighting up. Now, when we have traveled from here to here, it's important to keep a note of the distance that was traveled, because eventually we want to get to the endpoint there and we want the shortest possible travel distance. So the distance here is just the length of this segment in this case. We can go here and say other point distance is equal to the segment length. Simple as that. And now this point knows how far it is from the start point. And after this for loop here, we are done with the start point. We can mark it as visited. We don't need to worry about it anymore. All of the points connected to it have been processed. Now these attributes, distance and visited, we should set them in the beginning. So initialize them to something here. Let's loop through all of the points in the graph. And the distance, we set it to something really large. And I'm going to use the maximum possible value that we can use in JavaScript. So infinity, pretty much. And they are not visited. And now we expanded already from the start point, and we need to choose a new point, something that hasn't been visited yet, and expand from that one. So let's prepare for that and define here current point, set it to the start point, and let's give it a distance of 0, because we are starting from here, we haven't traveled at all, so it makes sense to put this here like that. And you can probably tell that this is going to loop, and this current point will update from start point to something else. So let's change now everything here where start appears to current point, and get a new point to loop this section. And it's going to be an unvisited point. So to keep things clear, let's define here unvisited. And we get that by using the filter method on the points and saying that we want the points that are not visited. We always want to expand the one with the shortest distance that we currently have. So it's also useful to take out these distances. And I'm going to use the map method here, remapping each point to just its distance. So this is an array of distances from all the points. And now to find the unvisited point with the smallest distance, we are going to find inside of this unvisited array the point with the distance equal to the minimum distance from this other array here. So the minimum function expects many parameters here, not an array like that, so we have to destructure it. And then it finds the point with the smallest distance. And this is the thing that loops. So we can try writing here a loop, for example, and let's just loop twice. So starting at 1, going to 2, I++, and everything here inside of this for loop, like so. And if you refresh, you're going to see that these two new points are marked there. And that's because in the first loop we visited this one, so expanding to process its neighbors. And in the second loop, this one expanded as well. Now, the distance that we are calculating here needs to be a cumulative distance. We need to add what was previously here to the new length of the segment that we are processing in this step. So here I'm going to type current point dot distance plus the segment length, because in the second loop this point here has already a distance, and that is important to be kept so that this point knows the travel distance from the starting point along this path, and this point now knows the travel distance from the starting point along this path. If you look closely, you're going to see a small issue here that this point is visited twice. It looks darker because of the transparency. And that is happening with the current logic, but it makes no sense because we move from here to here and then from here to here. So instead of this point having a distance of 0, which it originally had, it was the starting point, now it has double the length of this segment. We don't update these distances if we find larger ones. So here, let's also not add a point to the path in that case. So if this distance that we are calculating now, this current point distance plus segment length, is less than other point distance, then we do these things. Like so. If you save and refresh, you're going to see that this point is not emphasized anymore, because when expanding like that, it doesn't go back here, it's counterproductive. Let's try to expand more. Let's put here 3 and see what happens. You can see this expanded here. This one didn't expand here just yet, because we only expand from the point with the smallest travel distance that took to get there. So this one expanded, and most likely this is going to expand again and again and again. It's going to take some time until these distances here accumulate to the same value of this distance here. So let's try and see if that's true. Put the 4. Okay. Let's see 5. Growing here again. Let's see 6. Yeah. Let's see what happens next. I think that this distance starts to be almost the same as this one here. 7. Okay, so did this expand or did this expand? Let's see. Aha, it looks like actually this one expanded now, and these are the two new points. It helps to understand if we visualize the previous point it was connected to, highlighting this segment. Let me show you. Where we're updating this distance here, I'm going to type other point previous is equal to the current point. And now to visualize these in the graph editor, I can check if there is a previous. There might not be, like for the start point. Then we create a new segment from the point to the previous and we draw it. we can draw it on this context, and let's emphasize it with larger width so that it's obvious. Save and refresh. And now you can see that this point is connected to this one. So at the moment, it seems like the shortest path to get to this point is from here. But we haven't processed this point yet. This is not yet visited. That happens in the next step. So let's put here 8. And now you can see this update here. And it's showing twice because this point was added into the path array once when visited from here, and then it's updated. It's added again to the path with an update to its previous value here. So a little bit confusing visualization here, but this is correct now. It shows that this is the best way to reach this point. And the algorithm goes on, and it's going to end up eventually to the end point there. So we have to think about the stop condition, and it's not very complicated. We can just replace this with a while the end is not visited. And save, refresh, and now you can see the full path here. But we are not interested in this part from here. We just want to know how to get from the start to the end, right? And the trick is to backtrack from here. So from the end point, we are going to go back, all the way to the starting point. And that will be the shortest path from the start to the end. Let's go back to our code, and we don't need to create the path early on like this. We only do it after this loop ends. So let's remove also adding this other point. Here it was just for debugging. And here we can create the path again, like so, as an array. And let's loop again with this current point. Let's set it to be the end point. And now, while there is a current point, because the start point doesn't have a previous, so eventually this loop will terminate, we unshift the current point into the path. And this is the same as push, but it's putting it in the beginning of the array. So at the end, we're going to have the path in proper order. And update this current point to be the previous. Save and refresh, and you're going to see the path is correctly forming there. And this shortest path calculation is being executed on every frame. So if you're going to change the structure of the graph like this, you will see the path is updating as well. And if we're going to add here a new segment, then this new shortcut is going to be preferred over this one. So it seems to work. But one thing that I still want to do is we have added here these attributes to the points of the graph, and they are things that relate to this algorithm, and we should remove them from there so that other people working on this code, seeing that these attributes exist there, don't get confused. And actually, doing this is not really proper. Like adding attributes like this is not the best practice in the world. But alternative would be to create different structures with the metadata, and that would be just too much work. So this is a quick fix for that. And if you refresh, you will see that it still works, but those segments are not visible there anymore because this previous was removed. Now, we were able to test what happens on different graphs, but we should also be able to test what happens with different start and end points. Testing properly is really important no matter what you're developing. So let's try to add this feature next into the graph editor. We're going to go up where we are adding the event listeners here, and I'm going to add a way to mark a start point and an end point. And we'll do this by pressing the S and E keys on the keyboard while hovering a point. So let's add the event listener for key down to the window. And the callback function, first it checks if we are hovering a point. So like that. And now if the key that we have pressed is an S key, then we are going to set the start to hovered. We're also going to copy this below, and same thing for the E key, and this will be end as the attribute that we are going to store the value in. And now the display at the bottom is going to do here the shortest path, not between these hard-coded values there, but this start and this end. And it makes no sense to do this code when we don't have a start and an end. We will get an error. So we have to do here this check first. Now let's save and refresh. And you're not going to see anything yet. But if I'm going to press, for example, S while I'm hovering this point here, S, and now if I press E after hovering this other one, I'm going to get the shortest path from S to E. Let's see if we put here this as the end point and this as the start point. You can see this loop appearing here. So it seems to work. Let's try also the real world example. So going here in index.html, the index from the world again, and replacing the pathfinding world with this one. So I'm just swapping these here so that I have a reference of what is available. Save and refresh, and you're gonna get this world. But a little bit of a warning here. You can't move points here or add new points, click on this world or anything. You can, but if you do that, it's going to block the interface because this is a really big world and adding things to it manually, it's a really slow process. So safest thing to do is actually go down here where the world is generating inside of the animate function and comment that part out. When you refresh now, nothing is different, but if you try to add new points to this world or make modifications like drag this point around, it's not going to regenerate everything around it, like the roads and buildings and whatever. And if you accidentally click on something, you don't have to wait like, I don't know, 2-3 minutes for it to process. So let's see, does this work here? Let's say that this is going to be the start point. I'm going to press S, hovering this one. And let's put a destination, an endpoint somewhere here close to the target. So maybe here, E. And you can see it works almost perfectly. The problem is this was the start point. It's going up like that. And then here at the roundabout, this is bad. It's going in the opposite way here. In Finland, you drive on the right side of the road, so it should go on this way. And it's choosing the other one because it's apparently faster, like less distance to travel. This other place looks good. But we need to incorporate these one-way roads here. So these are essentially one-way roads here. You can only go this direction on this one and this direction on this one. And currently it's going opposite there. So we need to do a fix for that. And it's not complicated. We just have to go back to graph.js in our algorithm here. And instead of getting segments with point, we have to get segments that are leaving from the point. So get segments leaving from point, like this. And we need a function for that. It's not available here in the object. So I'm going to copy get segment with point below and rename this one get segments leaving from point, like that. And the logic is going to be quite similar. So here in the loop, if the segment is one way, we're going to have to do something special for that. But otherwise, if the segment allows to go both ways, then this is same as before. If the segment is one way, we have to only push into this segments array if the first point of the segment is equal to point. So if segment.p1 equals point, then push into the segments this segment that we are looping. And if you save, refresh, and now press here S, and let's add also the end location also close to this target as before. Now the path looks like this. It looks proper. So this is how you solve the issue about one-way roads. How was it? Did you understand Dijkstra's algorithm by coding it like this, or do you need a better explainer? Let me know in the comments. I could also teach more about it if you want, like how to make it more efficient or how to use it to compute some other path, like the fastest path, or how to include traffic information, whatever. My PhD was on location-based applications, so you can ask pretty much anything here. Next time, I'll show you how to make the cars stay on track. Thanks for watching and see you guys.